Hey everyone, Mr. Shatter here to take a look at some proof in regards to the derivatives of the 6 basic trigonometric functions. So let's see if we can examine why the derivatives are what they are. In order to take a look at some of the derivatives, we need to first prove this fact. So the limit as h approaches 0 of cosine h minus 1 over h. If I were to have to solve this, I would probably try to multiply by the conjugate of the numerator. The conjugate of the numerator is cosine h plus 1 over cosine h plus 1 on the bottom as well. And so the numerator is just going to equal the limit as h goes to 0 of, this is the difference of squares, so this would just be cosine squared h, and then minus 1, all over h times cosine h plus 1. Okay? And if I use one of my Pythagorean identities, I know that sine squared x plus cosine squared x is equal to 1. So if I minus a cosine x, I get sine squared x equals 1 minus cosine squared x. And that's almost what I have right here. I just need to flip it around. So divide by a negative 1. So sine squared x times negative 1 is equal to cosine squared x minus 1, because I can just now switch the sign. So this is what I'm going to use right here. So I can put this right up here. So this equals the limit as h goes to 0 of negative sine squared x over, I'm going to push this down, actually this should be an h as well, keeping the h's in this problem, over h times cosine h plus 1. Now since I have sine squared, that means I have two copies of sine. So what I'm going to do is break them up. So let's do the limit as h goes to 0. Let's use one of the sine h's, and the denominator, let's use the h. Because I recognize this as h goes to 0 as my theorem. This we learned in chapter 2. The value of this is just equal to 1. We're going to multiply by what's left, which is negative sine h over the denominator cosine h plus 1. So as I mentioned, the highlighted piece is just 1 because it's my theorem. And the piece that's left, I can just go ahead and plug a 0 right in here for my limit. And I get the numerator, if I plug a 0 in, I get 0. In the denominator, if I plug a 0 in, cosine of 0 is 1, plus 1 is 2. 0 divided by 2 is 0. So I know that the limit itself is equal to 0. Okay? So from now on, we can use the piece of information that we just proved. The limit as h approaches 0 of cosine h minus 1 over h is equal to 0. Okay? Let's see if we can use that to now prove the derivative of cosine x. Now we know the answer, right? We know the answer that we said earlier in the notes. The derivative of cosine x should be negative sine x. Let's see if we can prove it, okay? Using the definition of the derivative, that means we're going to do the limit as h approaches 0 of f of x plus h minus f of x, all divide h. And we're going to use cosine as my function. So this is going to equal the limit as h approaches 0 of cosine x plus h minus cosine of x, all divide h. And now I'm going to need to use a trig identity for cosine x plus h. So if you recall, cosine, we're going to do a little side note here, cosine of x plus h is equal to cosine of both angles, so cosine x, cosine h, and then minus sine of both angles, sine of x, sine of h. Okay, so I need to use this little tidbit, and I'm going to use it right, I'm going to put this right there for my highlighted region. So let's rewrite. This is going to equal the limit as h approaches 0 of cosine x, I'm going to get rid of the parentheses just for the sake of not having to write them all the time, cosine h minus sine x, sine h, minus the cosine x that's in the second piece, all divided by h. All right. Now, I do notice that this term right here, cosine x, cosine h, and this term right here, negative cosine x, they both contain a cosine x. So what if I were to group them together and factor it out? So why don't we take this guy, move him up for a sec, and take this, move it over to the edge, and then we'll put the negative cosine x right here. Okay? So now let's factor out a cosine x. So this is going to equal the limit as h approaches 0 of cosine x times, if I factor out a cosine x, what I'm left with is cosine h minus 1, minus sine x sine h. All divide h. Okay? And then we're going to keep going, and I'm going to identify that I know this is a lot like my theorem, right? Cosine h minus 1 over h is the piece that I just used in my theorem. So why don't we split this up? Let's split up this fraction into piece number 1, which will look like this, and piece number 2, we won't use red, we'll use pink. Piece number 2 will look like this. Okay? So let's rewrite. So this equals the limit as h approaches 0 of cosine x parentheses cosine h minus 1 over h minus the limit as h approaches 0 of, and we're going to do here, I already used the negative, okay? So this is just now sine x sine h over h, because the minus, I already used the negative, so I can call that a positive piece, okay? So this, as h approaches 0, is equal to 0. So I know that if I took cosine x and multiplied it by 0, that piece is equal to 0. Minus this, as h approaches 0, is my theorem again, and I know that's equal to 1. So what's left is my sine x times 1 on that side, which is of course equal to negative sine x. Thus, using the definition of the derivative, we've proved the derivative of cosine x is equal to negative sine x. Let's try proving the derivative of tan if we assume we already know the derivatives of sine and cosine have been found. So recall that tan x is equal to sine x over cosine x, right? So in order to take the derivative of sine x over cosine x, let's use the quotient rule. So low d high d low. So low d high minus high d low over low squared. And this is the quotient rule. So let's do it. So low is cosine x, so cosine x times the derivative of the high, that's the derivative of sine x, that's just a regular old cosine x, right? And then we're going to minus high, which is sine x, times derivative low, which is negative sine x, all divided by the low squared, which is cosine x, and we'll square the cosine, right? So this now is going to equal cosine squared x minus makes plus sine squared x all over cosine squared x. And I know from earlier in this video we said that cosine squared plus sine squared is equal to 1. So I'm just going to put a 1 here. So this is 1 over cosine squared x, which I know, now I'm just doing the reciprocal of cosine x, which I know to be secant. So secant squared x is my derivative. So most of the, or I should say all of the other trig functions, the 4 remaining trig functions, other than sine and cosine, they can all be derived. Their derivatives can be derived from just using either the quotient rule and just using the fact that we know the derivatives of cosine and sine.